Hello, and welcome to Conservation of Momentum in Inelastic Collisions. Now, these are the parts required to do the lab. We have two motion sensors, which will be giving us velocities as a function of time, which we will look at to help understand what's going on during the collision process. We also have two crash carts, both of which I've taken the mass of and will be in your spreadsheet for your lab. And we have our data acquisition sensor. Plus, we also have our track. Now, the setup is relatively easy for this lab. You put one motion sensor on one side, you put the other motion sensor on the other side, you make sure the track is nice and level, and then you basically crash the carts and allow them to stick. Now, what allows these to stick are bits of Velcro on the end, such that when they actually get into contact with each other in the proper way, let's see if I can do it like this. Here we go. They stick like that. So, in the next video, I'll show you the lab as set up and run an experiment. This is the lab as properly set up. We have our motion sensors at the end. Now remember, your motion sensor can be turned to people mode or cart mode. The difference between the two modes is the size of the target that you're trying to look at the motion of. And since these are carts and relatively small, we want the motion sensors to be in cart mode, which they are. Now, we're doing one run of this particular experiment. Our carts both start off 15 centimeters away from the face of the detector. So the one over here is at the 15 centimeter mark. Because the length of the track is 120 centimeters, this one sits at 105 centimeters. Now, the goal here is to get the carts to collide and then look at what happens before and after the collision, presuming they stick together. You may have to do one or two runs to get them to properly stick together. Some caveats that you might want to be aware of is that if you make the carts collide too quickly, a lot of times what happens is they actually bounce off of each other and they don't elastically stick, or inelastically stick rather. So, what we're going to do is to start from our positions here and then move them gently towards each other and let them collide, and then as you can see we have some exchange of momentum going on. Now what I would like to happen though is to have the cohesive unit move away at a much faster rate. So let me put this back at the 15 centimeter mark, which is right there. And I'll put this one back over here at the 105 centimeter mark, which is right here. And then we're going to collide them again. This time moving one slower and one a bit faster. There we go. That was a good run. Now, when you look in your spreadsheet for the lab, you'll see the data from the run along with the masses of the carts. The cart here on my left is cart number 2. The cart here on my right is cart number 1. Hi, and welcome to the theory section for Lab 6. Now, Lab 6 deals with conservation of momentum when applied to inelastic collisions. Now, remember, during the inelastic collision process, you have two objects potentially traveling towards each other, or perhaps one stationary, that impact, and after the impact, they go away as a composite object, an object that's joined. And during, again, the inelastic collision process, energy is not conserved. But in the absence of external forces, momentum is. Now, the theory for this lab is actually pretty easy. Since you have two carts that are traveling towards each other, let me sort of draw something here to simulate that. So here are our carts. We'll call it cart A and cart B. They both have initial velocities before the collision. I'll call this VA naught, and this is VB naught. Okay.
They have their masses, ma and mb. So this is before. Then they collide, and after the collision, depending upon which car is traveling the fastest and which one has the most momentum, basically, uh, we'll say it's going off to the right. You have your carts joined via a little piece of Velcro. We'll say it's going off to the right, like this. So you have a composite object whose mass is the mass of both combined, and whose velocity you will be able to get by looking at the data once you plot it. And the overall question here is, does the initial total momentum equal to the final total momentum? So our initial momentum in this case would be m sub a va naught plus m sub b vb naught. And the momentum after the collision is just going to be m sub a plus m sub b vb. Actually, not vb, v, sorry. Whoops, we'll go v. So the question is, obviously, does these two things equal each other? And again, by picking off the velocities off the curve that you get when you plot stuff before and after, and let's not forget that the sign matters here, because our momentum is a vector. So whenever you're taking and you're comparing the two, like for example, in this particular case, cart B is going to the left, this will have a negative momentum, and this will have a positive momentum, so it's going to the right. At the end of the day, this would have positive. So do not forget when you're doing your calculations to put the sign in. Okay. All right. So that's the theory section, and beyond that, it's pretty easy.